Welcome to my channel, Living Linux.
Hello! In this video I want to show you how I built Sherpa-Onnx on my Banana Pi F3 with the RISC-V SpaceMid chip. So in an earlier video I showed you Onnx Sherpa or Sherpa-Onnx on my Sipeed Lichee Console, but that one has a chip with vector instructions version 0.7. Now the Banana Pi F3 with the SpaceMid has vector instructions version 1.0, and these two are not compatible with each other in a sense that if you compile it as a binary, then it will work on one but not on the other. So they have binaries available, but last time that I tested it, it's with vector instructions version 0.7. So you need to do something else to get it working on the Banana Pi. I wanted to close this one. So here we have Sherpa-Onnx, and they have tutorials for installation. So let's just say in general it's quite easy to build it, especially if you're on x86, so Intel or AMD. And unfortunately this does not work without some small fixes on RISC-V, and currently even my fix no longer works because, well, they keep working on the repository, on the code base. And in October I tested it and I was able to get it working with a small fix, but I tried it again on a clean install, and then I noticed that some things were changed and my fix no longer worked. So, but luckily we can still build it in the same way as I did it back in October. So they also have instructions for RISC-V. So if we take a look here, then they provide a Colab notebook, because they're going to do a cross compile. So you can try to set it up on a Linux machine with an Intel or AMD chip. And well, it's a lot of steps, and yeah, because you're going to do a cross compile, it's not going to be fast. But yeah, anyone that want to have a go at it, feel free to do so. But yeah, be prepared to put some time into it. So this is not the way that I did it. So I just tried to do it just like this, and I got a clear error message with this step, and that was actually, well, for me, reasonably easy to fix. So if we go back, so yeah, this is one of the things that I noticed in the log. It's not an, let's just say, fatal error, but it's only a warning. But lib-a sound2-def was not installed. So yeah, it's a good idea to install it so that everything can get compiled. So that is actually a step before. And from there, well, let's just say this is currently the error that I got, and well, this didn't make any sense to me to see where I was able to try to get it fixed. So in October, I got a clearer error message, and that it said like, okay, in the directory build, deps, piper-phonemize source, CMakeList text, unsupported architecture for Onnx runtime. So now, if you execute this command, you will get the current code base, and well, perhaps from here, somewhere in the future, that it will start working on RISC-V and that you don't need to try to fix that I did. But as it is now, you have to put that fix in place. So you can get the code, you can go into the directory, and that's where you have to do a little fix. Well, at least this is a command to get the code as it was on the 1st of October. So you can try to play around with this date. Perhaps in the future that, yeah, we might can skip ahead to some other date in the future. So actually, usually you do it in 2 steps, so that this is actually one command, but you need to have the output of this command and then use it with git checkout. So the dollar says execute this command, and we take the output from this command and we use it with git checkout. So, but you can just execute it like this in 1 step. So once you are there, you can execute this command, or yeah, well, you have to make the build directory and go into the build directory, execute this command, cmake, and then probably you will run into this error message. Now, at least it is pointing you directly in the right direction. So let's just say we go into Sherpa-Onnx, build, deps, piper-phonemize source, and then CMakeLists.txt. So what I did is I added an extra entry for RISC-V. So I just copied the one for ARM and then pasted it here. And then I changed ARC64 into RISC-V 64 and also changed it here. So then just save it. And you can execute this command again. And well, at least for me, that's when it got to the end, and that you can compile all the executables. So once you have that, then you can get some pre-trained models. So I tried text-to-speech. And I used, yeah, fits Piper, Great Britain cement medium. So I'm a little bit lazy. Yeah. So this is where all the executables are built. I haven't tested it. I haven't tested them all. I only tested text-to-speech. And that's also where I put the model. So if we go to that directory, then I think it's probably still in my history. So this is the command to execute it. You need to specify the model. And also a data dir tokens. You can specify the number of threads. So in my case, I got the best results with 4 threads. I have 8 cores, but letting it run on all 8 cores actually made it just slightly slower on my machine. And you can specify the output file name. And once you have all that, then you can specify the text that you want to generate as speech. So just to show you the speed, I mean, it was already generated because that was the file that was played when we started the video. But just to show you the speed, so it needs to load the model, and then it says it generated it in 1.7 seconds, and that the speech is actually 2.5 seconds. So the real-time factor is let's just say 0.7. So once the model is loaded, then it can generate the speech faster than the duration of the audio. But yeah, you have to compensate for loading of the model. So yeah, it's a bit of a question if they are going to provide executables for both RISC-V factor 0.7 and 1.0. Yeah, because I'm not really sure if my fix will keep working. I'm not a developer, so yeah, it's also a lot of code, so yeah, that's a bit hard for me to guess if this will keep working just by going to the code base as it was in October. Because yeah, here you have a link to the precompiled binaries. Yeah, to be honest, I haven't tested this one, but with earlier versions, then it only worked on my Sipeed Lichee Console and not on my Banana Pi. So, but the good thing is that at least now we have 2 options. So if you have a chip with factor instructions 0.7, then you can use these executables. And when you have a chip with factor instructions 1.0, you can try to compile it yourself just with a little fix. But there's no guarantee that this will keep working. Or perhaps the positive scenario that perhaps in the future we can build it directly on RISC-V without having to make any fixes. So that's all for now, and I hope to see you again in my next video.